evening, everyone, wherever you're joining us from. I hope everybody's well and beginning to see some light at the chinks of light in this situation we're in, and looking like we're coming towards the end of lockdown, certainly in the UK, and looking forward to getting out and getting back amongst people. I'm Thomas Neeson, I'm managing partner at Condor, and today I'm really pleased to welcome you to our latest webinar, which is, as the slide says, Earth Day. What does the industry need to do ahead of COP26, which will be held later on in the year? It's a significant day, being Earth Day. It's obviously been rolling since 1970, set up in the US. This is the 51st Earth Day, and today's theme is Restore the Earth. So more than just minimizing our impact on the Earth, we've got to look to how we actually restore the planet that we all live in and on and depend upon. Today is also a significant day because the US Biden administration are holding their climate summit today with 40 world leaders, and that shows a return to the table by the US. And obviously the impact on the world is going to rely upon the big players, US and China, getting on board. So it'll be interesting to see what comes out of that summit today. I don't know if you want to next slide there. Richard's running the slides. Yeah, just a little bit about Condor. Yeah, we're a practice, for those that don't know, we're a practice of engineers across the globe. These are our locations in dark blue. So we cover everywhere between Ireland and Australia. The great thing about that is it brings us lots of experience, lots of talent from around the world to input into things that we can then influence across all the regions we work in. So we'll have sustainability specialists in Australia, Singapore, and China, Hong Kong, inputting into things that we can pick up in the UK and vice versa and apply in the Middle East and across all of the parts of the world that we work in. Next slide, please. Yeah, and to do that, we deliver all engineering services. What we're doing here in sustainability is just one part of it. But obviously, the impact we have in sustainability factors in all of both our services that we offer and our sectors, which are on the next slide. So we work across all types of buildings and master plan and infrastructure. And the aim always is to deliver the most sustainable solutions that we can as we deliver our projects going forward. On the next one, I don't know. So that's a summary. With 21 offices, we've been going since 1976. And with 950 people worldwide focused on this. We have a target for net zero carbon design by 2030 for everything that we do. And this is just one step on that journey. On your next one. We did achieve becoming the first carbon neutral engineering consultancy in September last year, something we're very proud of and something that we're working hard to make sure that we build on now. So rather than just look at our own impacts, the biggest impact we can make is in the projects we deliver. And that's part of what we're doing here today, to educate, to absorb knowledge, to pick up things from all of you that have joined in. And together we learn and move forward. So our next slide. I just wanted to quickly introduce you to our speakers. So these are in order of how our speakers will present this morning. First up will be Richard. Richard's our lead on net zero carbon. Richard's got a long background in time with the UK Green Building Council, where he led on advancing the net zero carbon program then, and then Richard joined us. So sorry to the UK Green Building Council for taking him off you, but the great work that he's done there, he'll build on here and be able to drive through projects and through industry, and will lead us on that. He'll be followed by Qian Li, and Qian is specialist in material life cycle assessments. Well known and respected throughout the industry. Qian inputs into lots of publications and lots of standard codes, for example, for the RICS and the REBA statements on life cycle, to make sure that we're integrated through the industry and can help all move forward with their projects. And then followed up by Jennifer Elias. Jen leads our section in Condor on building performance and assessment and optimization. And Jen helped to bring neighbours to the UK to deliver that, and also sits on the UK Green Building Council's Whole Life Carbon Task Force, with a lot of input to be made before COP26 and beyond. I mean, COP26 is just a milestone on the path. So 3 really good speakers. We've got about 30 minutes of talk. Then we'll have a Q&A session, but please post your questions and answers as we work through the presentation. We'll have time for discussion at the end. If we don't get through all the questions, we'll respond to you individually, as long as you give us your name on the question. So lots to learn together. So please contribute, join in, ask your questions, and enjoy the webinar. And I'll now hand you over to Richard to start proceedings. So thank you, Richard.
Thank you very much, Thomas, and good morning to everyone. I'm going to start the session today just by running through some of the background on COP26. What is it? What is the link with net zero carbon that we keep hearing about, and what the industry needs to take note of? What are the actions that we need to be taking out of these developments ahead of COP this year? So starting with COP26, what actually is it? COP is an annual UN global climate summit. It's due to be hosted in Glasgow in November this year. It was meant to be hosted last year, but was delayed for obvious reasons. You probably heard of the Paris Agreement, which was thrashed out and agreed at COP21. Which was back in 2015. And COP26 is really the first major milestone towards actually delivering against the Paris Agreement. The reason for that is that every 5 years, or in this case 6 because of the delay, all of the signatories to the Paris Agreement are required to come back to the table with their own updated so-called nationally determined contributions, or NDCs. These are basically the voluntary contributions that each country makes in terms of carbon reductions, which should all add up towards the outcomes of the Paris Agreement. Now, the reason why it's so important this time around is because even in the few years since the Paris Agreement, our understanding of the climate science has moved on significantly. At the time, the main objective was to limit global warming to well below 2 degrees. For context, we're currently at 1.1 degree of warming already. But we have since move towards accepting 1.5 degrees as actually our new target, because in recent years we've realized that actually the difference between just 1.5 and 2 degrees is orders of magnitude worse in terms of the climate impacts. For example, we could be talking about losing double the number of species as a result of climate change from just that ½ degree extra. The problem is that 1.5 degrees is very difficult to achieve. Globally, that means we need to be halving emissions by 2030, and it means we need to be achieving net zero globally by the middle of this century. And that is why COP26 has been called the Net Zero COP. Because any country worth their salt needs to be coming along to Glasgow in November this year with a net zero carbon target. Simply put, anything else doesn't really cut it at this stage. But it's not just countries that are going to be coming along and looking at net zero. For the first time, businesses are also being actively encouraged to get involved in the COP process. The Race to Zero campaign is the official umbrella campaign that's been set up by the UN to allow that. And it's acting as an umbrella for all of these different initiatives that you see here, each of which are designed to help businesses both set and deliver against net zero carbon targets. But the area where we have probably seen the most movement in the past few years has arguably been from finance and investment. Even quicker than most governments have moved. In fact, the investment community has really got behind net zero because of the risks posed by long-term climate change. Here we've got just a couple of examples of the way investors are starting to up the ante on net zero. 6 months ago, a major group of global investors representing tens of billions worth of assets signed an open letter calling on the businesses that they invest in to set science-based targets. Now, this is a significant development because it's investors saying to businesses, you need to get your house in order. You need to be in line with the climate science. Otherwise, you are going to lose investment. Secondly, just in the recent months, we've seen the publication of the Net Zero Investment Framework. So this is designed to help institutional investors to reallocate their investments towards only assets which are Paris aligned, that are aligned with the Paris Agreement. And for buildings, it specifically flags up the Krem tool as the means of understanding whether an asset is Paris aligned. So I'm just going to quickly run through what are some of the major implications of these two initiatives in particular, and what the built environment sector really needs to be taking note of in the transition to net zero and in the run up to COP26. Firstly, science-based targets. So at the moment, these are targets which are mainly for businesses' major operations, so your scope 1 and 2 emissions, what you emit directly, and the energy you use. And it's about setting an absolute reduction trajectory, which is in line with the climate science, as the name suggests. But Science-Based Targets Initiative have recently started consulting on a new protocol for setting net zero carbon targets for businesses and organizations. And that's represented by the chart that we've got here on the left. Now, this is still all to be confirmed. It's going through a consultation process, but there are 3 key principles which have been guiding this and which will make their way through into the final protocol. Firstly, any net zero target that is credible must be underlined by absolute reduction targets, which are in line with a 1.5 degree trajectory. That means even if you have a date for net zero carbon, you've made a commitment around that, you still need to be reducing your emissions in absolute terms by at least 4.8% every year. That is what that means. Secondly, any remaining emissions, in order to achieve your net zero outcome, need to be met through robust carbon removal offsets. So these are not your bog standard offsets that you can buy today. These are things like carbon capture and storage, which is going to be technologically more difficult and much more expensive. And thirdly, and most importantly, I would say, any target for net zero must include value chain emissions. So these are also known as scope 3 emissions and are associated with the wider operation of a business. For the built environment, that means 2 things. That means for asset owners, it means understanding how your tenants are using buildings. And for construction projects, it means understanding embodied carbon. So by pushing science-based targets, investors are in effect calling on asset owners to understand how tenants are using their buildings, and for construction projects to be setting embodied carbon targets in line with the climate science. Just to be clear, that means at least a 50% reduction by 2030. And Qian is going to take us through the process of how you start looking at embodied carbon and making those sorts of reductions shortly. Secondly, Krem. So this is a relatively new tool which is aimed at creating science-based targets for individual commercial real estate assets. That science-based target is represented by that green line that you see on this graph. The idea is that you plug in data about your asset, which is that black line, and it projects forward to indicate when, without improvement, that asset would exceed its science-based target. at what point it would become classed as a stranded asset. And that is that little red dot there. That is called a stranding event, which at the moment is positioned over 2032 for this particular asset. Now, that stranding event is not a regulatory event of any sort, but this tool is going to be used by investors to understand risk. That means assets that are classed as stranded will have a brown discount applied to them in the future. They will actively be devalued by investors because they are classed as stranded. Of course, one of the problems with tools like this is the accuracy of the outcome is only ever determined by the quality of the data that you're putting in. So just as an example, we all know that EPCs are very poor predictors of in-use performance. We could be talking about a margin of error of plus or minus 50%, which is probably a bit generous actually, but let's go with that for now. What that means, if you plug that into the Krem tool, is you could be talking about a stranding event happening at any point between mid-2025s and the early 2040s. That is a margin of error of over 15 years across just a 29-year period to get to net zero carbon. If you are using EPC data to understand the risk profile of your asset, you effectively have no idea at what point your building is going to start losing value and attract a brown discount, at what point it's going to become stranded. That is why it is critical we understand the in-use performance of our assets, because that is the way that risk is going to be understood. And that is the way we can get our buildings towards Paris-proof energy performance targets, is by looking purely at the in-use energy performance. My colleague Jen is going to look at what you should be doing on that front in a bit. But I'm first going to hand over to Qian, who's going to take you through the process for embodied carbon.
All right, thank you, Richard. Morning, everybody, or afternoon or evening to where you're sitting. And yeah, I mean, I'll be talking about the embodied carbon, which is part of the Scope 3 emission that Richard mentioned. Next, please. This diagram is it's a couple years old, but that can shows you the breakdown of carbon emissions through the construction industry. And you can see the building material and the activities during construction accounts for 11% of the emission in the building environment. But again, with the building operations and other factors becoming, or transportation becoming more efficient over the years, this proportion from building materials will eventually grow if you don't look at it clearly or don't focus on this now. Next, please. How we monitor and how we review the whole life carbon, there's a British standard, there's a European standard to look at it from the production stage to the end of life stage. So effectively, you need to look at where your material is made, how it is made, the way it is made. Is it using renewable energy during the manufacturing process, or is the manufacturing process very efficient or very wasteful? And again, are you using recycled material to make your product, or is only virgin material you can only use? And of course, how far the material after being made need to be transported to your site. That matter with local sourcing, local economy, and a few other aspects you need to consider. And also the type of material and type of construction method you design, you're trying to go with, will have a direct impact on the amount of time you spend on site. That will lead to the emission during the construction. And also, once you finish with that, that's kind of your building is being completed. But your emission doesn't stop there. You spend materials and energy in the operation of your building. And Jen will go through the operational side, but for example, you also need to replace carpets, partitions, and facades and maybe equipment over the lifespan of your building. And also towards the end of the life, how your building is designed will make a direct impact on the deconstruction, reusability, and recyclability of your materials. Say if is your building is only be able to be demolished and crushed for landfill or reused for aggregate and downcycle basically, or are your building be able to be deconstructed quite easily, and that will lead to an impact of battery reuse, recycle recovery. That's the module D, and also that's the whole circle is called circular economy principle. It's that you design, enable your building to be reused and recycled easily. Next, please. And as Thomas mentioned earlier, we were involved in producing quite a few of the methodologies guidance in the industry. We were involved in the RCS professional statement to explain to people how and what assumptions you have to make during your whole life carbon assessment. And also we produce something similar for the RBA, for the architect to look at what stages you need to be look in to consider what element for your building to achieve better efficiency of reduction. And also there's a LETI publication giving lots of fantastic examples and guidance on how to reduce embodied carbon from different parts of your building. And more recently, Condor were commissioned by Great London Authority to produce the whole life carbon assessment guidance for the London plan. Basically, that when you submit your plan application for big project, you need to do a whole life carbon assessment following this methodology. Next, please. This is a graph of the buildings we assessed in the last couple of years. Most project in UK and with London and sort of UK commercial office focus. The average carbon emission of all the building we assessed so far is about 1,000 kilograms CO2 per square meter. And the benchmark or the sort of common practice we set for the Great London Authority is about 900 to 1,000 kilograms CO2 per square meter. But to achieve any sort of a meaningful target set either by LETI or RBA or even some other organizations, you can see we're still gonna be a long way to achieve. I mean, this is talking about 40 or 60% reduction we need to look at. So that will call for a dramatic change or reconsideration on how you design and procure and build your buildings. Next. And one of the first or the easiest or the most efficient way to do this is retention of your structure if you have an existing building on site. This is the example in Victoria, and by retaining the substructure and superstructure, and they also managed to add in new floor areas on the top of some sort of minor extension to the top, and also infilled some of the atriums. But that will provide enough space or additional floor space to make this building financially viable. But also by retaining the structure, they managed to save over 25% of embodied carbon quite easily basically from day 1 or day 10. But when they set the brief, they actually got a much better starting point. Next, please. And in Condor, we realize or understand how important it is to incorporate this early in design stage. We have incorporated the embodied carbon assessment process in our Revit model. So when the structural team or the MEP team, when they start look at design options early stage, they could select, or they at common practice now, they will need to select materials appropriately, and also depending on the different build-ups of the scenario of their option, there will be a embodied carbon estimation associated with it. This way, we and the team can identify which option is more optimized on embodied carbon, which one is less so. But of course, we're not perfect. In some scenario, if we cannot, for any reason, going for the low embodied carbon option, there might be some other options we need to still to look at. But this way, we can also identify which part of that option have higher carbon impact. We can focus on that part to say how can we reduce impact from that area. Next. And apart from the building structures, in terms of building fit out, again, it's another quite it's going to be another quite important factor is the fit out, because the fit out again is not only is quite visual, quite tangible for people to visualize, and also those things might go through replacement cycles. If you haven't designed them properly, will make them more difficult to replace. Or if you use renewable low impact materials or easily replaceable materials, you actually can reduce the impact over lifespan as well. For example, you can use things like a cork in your sort of area because it's quite organic material and easy to be recycled, reused. You can reclaim recycled floor panels. Okay, we can use more organic finishing materials in the ceilings. And this is the UK GBC office. Again, they use lots of reclaimed and even second-hand material be refurbished. Even in the glass partitions is from a reclaimed source. I think that's the end of my slides. And back to you, Richard.
Thanks very much, Qian. So we'll now hand over to Jen, who's going to run us through some of the steps that you need to be looking at in terms of in-use energy performance.
Yeah, thanks very much. So I think it's helpful if we sort of start off by recapping some of the Paris Proof targets that Richard mentioned earlier. So when we talk about Paris Proof in the context of operational energy, what we're looking at doing here is matching the demand of energy within the economy with the amount of renewable energy that we can supply as an economy. And so you can see this sort of illustrated in the slide here, where over time we're looking to increase the amount of renewables, that's the grey section at the bottom, but at the same time, we need to significantly reduce demand right across the economy, but across all building sectors as well. And that means that when we start talking about operational energy, it's important that we don't get so concentrated on offsets that we realize that actually, hang on, there's not enough to go around for everyone. So we need to, across all sectors, significantly reduce our energy demand to achieve a net zero carbon economy. On the next slide, I've sort of snipped from a few different industry bodies, the UK Green Building Council, the RIBA, the London Energy Transformation Initiative, who over the last sort of year and a half have all put together trajectories for energy use intensity within buildings. And they've all these organisations have come to the similar conclusion that we need to make about a 60% reduction in energy demand in buildings by 2030. And so if we go on to the next slide, it's important to realise that the methods that we have available, as Richard's mentioned, in terms of energy performance certificates in particular, they're just not doing what we need them to do in terms of reflecting actual operational energy usage. So in this chart, it's quite a classic, and I think a classic for a reason. We've got the EPC band for a variety of buildings along the horizontal axis, from A being the best to G being the worst. And then those buildings' actual measured operational energy consumption along the vertical axis. And you can see immediately that there's not really any correlation between the EPC band a building is achieving and its in-use operational energy. I've also marked on the chart, if you can see there in the blue line, where the Paris Proof net zero carbon targets set by the RIBA, the UK GBC and LETI sit in relation to operational energy as measured in this chart. And you can see immediately that that's a really significant reduction for operational energy in buildings in the UK. So moving on to the first action before COP26 is really in existing buildings. Now, Condor have developed these 7 steps to net zero carbon, but for existing buildings, we really want to focus on step 2, reducing operational energy demand and consumption, and step 3, eliminating fossil fuels from buildings. So what does that mean in the first step, reducing operational energy demand and consumption? The first thing is to really understand the performance gap. Here I've just pulled out buildings with the EPC rating of B from that previous chart, and I've looked to essentially illustrate here with buildings that achieve an EPC rating of B, they have a very good facade, they have very good mechanical services usually, but there's still this huge performance gap from the best performing to the worst performing buildings. The first thing we need to come to grips with is data quality issues. And there's going to be data quality issues at both the top end and the lower end of the building. We need to understand exactly how much energy our buildings are using and that make sure that we have data in place that's recording that accurately. The next thing to consider is occupant behaviour. And we all know that different occupants will use different buildings differently and that different occupiers have different expectations. We're not going to be able to have as direct an impact on that. As Richard said, though, we need to engage with our occupiers and understand how they need to use the building and work with them to ensure that they're doing that as efficiently as they possibly can. However, that's not going to solve the problem on its own. We've got in existing buildings a lot of issues in the UK around poor control setup parasitic loads, things that were put in the building 10 years ago for a specific purpose, that have just stayed in the building even though that purpose is no longer needed. We need to go into our existing buildings, understand the control setup, optimize that for the way the building is being used now, and look to eliminate as many of those parasitic loads as possible. Once we've done that, there's still a last issue here around unintended design consequences, where the original designers of the building had one use case in mind and designed systems around that particular use case that has led to some unintended consequences for the way we're using buildings today. Going into our existing buildings and understanding how the control setup and the original design are impacting on current occupant behaviour is really key to closing that performance gap. And then on the next slide, we've got an example of how we've done this for one building in London. This is a building that's on a very constrained site in the centre of London, where the chillers had come to their end of life. And we wanted to use this opportunity to get rid of the gas boilers in the building as well. So what we did was undertake an evaluation of the suitability of 4-pipe heat pumps. These are essentially chillers that recover heat off the cooling cycle and use that to heat the building. Through doing this appraisal and using building simulation and optimization techniques, we were able to demonstrate that we could do a fossil fuel-free changeover in this building without creating additional plant space. And that's a really great way to save energy as well as eliminate fossil fuels from your building. For new builds, however, we need to make sure that we're prepared to verify the energy consumption in our buildings. So there's two ways of doing this. The first is the display energy certificate, which has been around in the UK industry for quite some time. And this is a great tool for whole building assessments. Owner-occupied buildings, for example, public buildings must display a display energy certificate. The trouble is where you've got a commercial office asset where you're leasing that space out to tenants, it can be very difficult to achieve a fair rating because you're essentially being rated for the behaviour of other people within your building, specifically your tenants. Neighbours UK launched in November last year and aims to bring over the Australian methodology that's delivered such success in reducing operational energy in Australia by separating out the rating for things that are within the landlord control versus things that are within the tenant control. But it's important to be prepared to undertake an in-use performance verification by either of these methods, depending on the scope of the building. And when we talk about Neighbours UK splitting between landlord and tenant, it's important to realise that this distinction is made around the idea of what is in the landlord's control, including obviously lifts, common area lighting and power, but also all of the air conditioning energy within that entire building. What this also means at the bottom of the slide there is we can then exclude any tenant energy, which I've mentioned, any retail energy, if there's any data center style computer rooms, for example. But of course, this needs to be excluded using data, and that data needs to come from submeters within the building. And these submeters need to be very clearly identified in schematics, and they need to be validated annually to confirm that the data that they're reporting is correct. It's important that we prepare to verify under these schemes by understanding how our building submetering systems are working, whether there's any data quality issues, and making sure that we are able to achieve fair ratings when we move over to Neighbours UK and split between landlord and tenant. On the next slide is a great case study that we've done for one of our clients. This is 5 buildings from one portfolio, and we looked at the way the Neighbours UK rules would apply to these buildings in advance of the scheme launching. What we found was there were some issues around high energy usage and that performance gap that I've mentioned earlier, but then also just some more basic level data quality issues, submetering schematics that were out of date, record keeping that hadn't been kept up to date in accordance with the rules of the scheme. And these are things that these buildings can now implement ahead of the taking on board the Neighbours UK scheme. They're able to position themselves as leaders within the field. And it's important that all existing buildings start to come to grips with how they're going to go about verifying performance to make sure that they're going to get a fair rating at the end of the day. Obviously, if we move on to new builds, there's some really key actions here as well for buildings that are not currently in operation and that don't have operational energy data. So when we talk about the 60% reduction in energy to achieve these Paris-proof targets, what does that really mean? And I've put here some results from some detailed simulation modelling that we at Condor have performed, looking at, on the left-hand side there, a typical new office building, and then on the right side, a net zero carbon Paris-proof new building. And you can see that there's significant savings that need to be made out of IT and tenants more power, but more particularly some really significant savings in terms of air conditioning and HVAC energy use. These models take into account all uses in the building, including sort of ancillary uses, diesel sump heaters, CCTV, access control, etc. It's important to do these models in a very detailed way to make sure that we are accurately predicting energy use in operation. And applying this methodology on the next slide is really about implementing a design for performance methodology and approach. Now, the Neighbours UK scheme last week launched the Design for Performance Agreement, which enables new commercial buildings to sign an agreement committing to a target, and then after undertaking the detailed simulation work that comes with that and having that peer reviewed, they can then promote a Neighbours UK rating ahead of the development and the completion of the scheme. That allows them to promote a Neighbours UK rating, for example, to potential tenants. However, we would really recommend a design for performance approach be followed by all assets. So at the start of the process, committing to a target upfront, simulating using either the design for performance methodology for commercial base buildings or the CIBSI's TM54 methodology for other buildings. But then it's really important to have that rating, the simulation peer reviewed by one of the panel of experts that have been identified by the design for performance methodology. And it's important to have that peer review so that we can all collaborate, share knowledge, share best practice, and make sure that our simulations are really up to date and accurate. And then finally, moving into operation, we need to be prepared to disclose our performance publicly every year using either the Design for Performance, the Neighbours UK certificate, or the Display Energy certificate. And I think coming to grips with this idea of disclosing performance annually is really one of the key parts of actions for both new builds and existing builds ahead of COP26. So I'll pass over to Rich just to sum up, but thanks everyone.
Thanks very much, Jen. So that brings us to the end of the presentations for today's webinar. Just before we move into the Q&A, I'm just going to recap sort of some of what we've run through in terms of the presentations. Firstly, looking at COP26, obviously there isn't necessarily a direct link between COP26 and a building project, but it is going to have an impact for the construction industry through investors and the pressures that will be put on businesses through that process in terms of setting net zero carbon targets and the sorts of requirements that are going to be required of projects and construction businesses over the next few years. In terms of buildings in particular, on the route to net zero carbon, we are going to be held accountable on both embodied carbon and on in-use performance. We need to be recognizing that and moving on those as soon as possible. This is how we gear up for net zero. In terms of embodied carbon, we're looking at potentially very significant reductions that need to happen in the next 10 years. Along a science-based trajectory, you'd be looking at cutting by at least 50% by 2030. The first step towards that is always measuring. It's understanding through the design process what the main opportunities are and trying to take those wherever they sit, because 50% is very difficult. Let's not make any bones about it. We need to be getting started on that sooner rather than later. And then in terms of in-use energy performance for new buildings, as Jen said, we should all be going through a design for performance process. That can be done for most commercial real estate projects in terms of a design performance agreement at the moment, but this really should be becoming standard practice across the industry, regardless of what type of asset it is. And then lastly, for existing buildings, this is going to be where one of the main challenges sits in terms of understanding the performance of existing buildings and driving those down to those Paris-proof targets. So for those, the first step that we need to be taking is getting your house in order, understanding how those buildings are performing and preparing to publicly disclose in-use performance, because that is how they are going to be judged. So just to finish, to say sort of Condor's actively involved in quite a lot of setting the standards around embodied carbon and operational energy at the moment. If you are left in any doubt as to what you need to be doing as a business in the move towards net zero, come and speak to us. Or if you know what you need to be doing and you just need some help, please do come and talk to us about that. So we'll move on to the Q&A now. So Nella, do we have any questions coming through?
We do. Thank you, Richard. And thank you to Jen and Chan and also to Thomas for doing the intro for us today. Just a reminder that if you have any questions, please use the Q&A box and we will start answering them. So this first one from Adam Vaughan, it says, I agree that data is key to driving down emissions. What opportunities will near-term future technologies bring for collecting data in operational energy use and embodied carbon and making that widely and transparently available? Who wants to take this one?
Yeah, I can start from the operational perspective, and I think there's a really, really big part for smart buildings to play here in terms of linking smart meters to individual sort of building-based servers to show that the consumption within the building and help the building be managed more efficiently, but also then disclose that more broadly. The only hesitation I'd say from the operational perspective is we have a lot of experience looking at submetering data at Condor, and the chances that all of that submetering data is right is almost negligible. It's important that we don't see data as a silver bullet, because it does require maintenance, it does require tracking, it does require validation, and it's important to make sure that the data's right before we rely on it more broadly within the industry to drive performance.
Well, can I just add on the embodied carbon bit? And although there's at the moment there's a sort of a getting better, but there's still limits amount of data available for embodied carbon. And there are some databases and there's some online platforms. People are putting the result up there, like a RAP database, and also that when the GLA is enforcing the whole life carbon assessment, they will probably put the result somewhere as well. And also there are databases for you can use search for EPDs. There's a database you can look at for the embodied carbon values. So they're just getting there, but haven't been a centralized database that we can refer to the same source. They're still sort of scattered around. But I think as more people doing it, the data transparency, the accuracy will improve.
Yeah, and I think sorry, just to add to that, I think particularly on the embodied carbon side, the reliance at the moment on generic data could potentially trip us up in the future. We need to be focusing on sort of product and material level data based on where that is actually produced, how it's transported, that sort of thing. So automating the data process with manufacturers and through the procurement process is going to be very important to understanding what our Scope 3 emissions really actually are.
Great, just moving on to the next question. This one's from Eduardo Gayton. It says, it has been mentioned that we need to reduce the demand, even of new energies. Jevons paradox clearly says that the increase of efficiency of a resource increases the demand as well. This will be creating a different issue if we do the wrong assumption. We might be forecasting our behavior related to energy consumption in a very unreal canvas. Any thoughts?
Jen, do you want to go on?
No, you go, yeah.
Okay, so I think this is part of the issue from a technical perspective, that we cannot simply design buildings and say that is net zero carbon. That is not the end of the story. It's also about engaging with the end users, excuse me, in order to ensure that they are actually using the building properly. And that is where the link starts to come between the project level and the organizational level. It's not simply about a project team coming up with the design and they hand over to asset management and that is job done. It needs to be about the process of effectively more robust soft landings. We need to be properly understanding how tenants should be using them. And if tenants have specific requirements, if they're failing to meet what is expected, it's about going and engaging with them and trying to work out solutions on an ongoing basis. Not simply saying it's not our problem, they're messing it up for us, but actively working with tenants and with landlords in order to come up with the optimum solution.
Okay, next question. This one from Paul Kenyon. Is there a standard green lease available that will help to drive tenant behaviours?
So the simple answer is no, unfortunately. There is guidance out there on setting green leases. So Better Buildings Partnership in particular have produced some very good guidance on how you can set up green leases. But I would say it's still a very ad hoc process out in the market. It's still being done on a very individual business basis. Leases are, after all, very complicated processes, but I imagine over the next few years, as these start to become more standard and we start to understand that there is more of a requirement for data sharing and for collaboration, that there's likely to become more standardization in the sorts of clauses you do see in green leases. At the moment, as I say, there is just guidance out there to help you set your own rather than standard leases that we can be using.
Thank you. This next one from Stephen Dixon, who actually has two questions, one for Jen and one for Richard. For Jen, it is NABERS sufficient guidance to help consultancies start on the path to accurate energy measurement in a rented office space?
Yeah, so that's definitely my recommendation, to follow the NABERS guidance, both in terms of estimations at design stage, but then obviously following through the NABERS rules to energy measurement in operational offices. But I think it's important to recognise, and I think you've sort of recognised this in your question as well, that it's a starting point. We need to start by undertaking the most accurate predictions we possibly can, but then making sure that that's not the finishing point, that we are going back into buildings, comparing the operational data against our simulation model and working out, okay, what could we learn from that building to make our simulations better? What could we learn from that building handover process, from the soft landings process, to feed that back into a continuous improvement cycle for our buildings? NABERS is absolutely the right starting point, but it's important to realise that it's not the silver bullet here.
Great, thank you. And for Richard, specific carbon offsets, so not just planting trees then?
So there's still a bit of a debate about this, it has to be said. Planting trees is pretty much the closest you can get to a robust carbon removal at the moment. Although, no, that's even oversimplifying it. It should be about supporting ecosystems. Simply planting trees won't necessarily have the same kind of impact as trying to actually manage forestry properly. However, there is still a debate to be had about whether or not that should be classed as a robust long-term offset for net zero carbon, because trees have a habit of doing things like burning down, particularly with climate change and increases in wildfires, which means they are a partial solution. Not all of them are going to burn down, obviously, but they aren't necessarily as secure as they need to be. So we're likely to see a move towards what's called carbon removals with long-term storage. Things like direct carbon capture from the air and storage underground of carbon until we can work out what to actually do with it in the future, probably through manufacturing. These are new technologies which are not economically viable at the moment, but they are likely to become a core part of net zero carbon because they add just an extra level of robustness. They lock in carbon an awful lot better than trees can. So I would say sort of trees and forestry is a good thing to be doing at the moment, but it's probably not the end solution. And whether or not you're going to be able to get away with that in 30 years' time is still a bit of an open question.
Thank you. This next one from Roy Kinsey. Reference was made to the whole life carbon plan in terms of planning consent. How many districts and boroughs are enforcing this currently?
I'll take this. And at the moment, the Greenland Authority have required all the referrable schemes, basically like a planning applications with a bigger scale, is mandatory to do this exercise. It's not mandatory at the moment for specific boroughs or for project that does not need to be referred to mayor. But we start to see lots of planners in different boroughs start asking the question, if it's sort of on the cusp of referable, non-referable, sort of medium scale project, they start asking for this. Although it's not mandatory, but we've been seeing there's a lot of requests, at least people to consider this. But for referable schemes, that is a must to carry out this study. Okay.
Great, thank you, Chan. This next one from David Furness. Could you summarize your view of what the key criteria or measures that an investor should be building into their investment decision making for either existing or new buildings?
It's a good question, and I think it probably comes back to most of what we were presenting. So the level of accuracy on the data that you're looking at. So you should be looking at what is the with a new project. If you're investing in that, you need to be looking at what kind of whole life carbon assessments are being undertaken, and how can you be driving those down in line with your science-based trajectory. I would expect as an investor, you should have some sort of science-based target yourself. And so is it compliant with that is a very simple thing. And what kind of data actually sits behind that whole life carbon assessment? Make sure you're getting it third party reviewed. From an operational energy perspective, making sure that you have that design for performance process in place. And again, that it is setting ambitious targets which are in line with both the industry guidance, which Jen mentioned, so the likes of LETI, UKGBC and REBA, which represents best practice in this case. But then also mapping it against the Krem trajectory that I mentioned, which is effectively your backstop. That is the point at which the worst buildings will get stranded and start to lose their value. So look at what kind of data there is available in terms of whole life carbon and in terms of operational energy. What kind of assessments are being undertaken against those in order to understand how accurate they are and how they sit against the science-based reduction trajectory.
Thank you, Richard. This next one from Jordan Evans. Appreciate we've all been working from home a lot more over the last year. Will this help with reducing operational energy and demand for office buildings throughout the UK? Or is it just changing the sector from industry to domestic from an energy consumption point of view?
Yeah, and I think there's a similar question sort of a couple of lines down just around whether we've seen any data emerge on how the shift to home working has changed consumption at a sort of industry-wide level. The short answer is yes, it is moving energy from one place to another. My suspicion is that it's increasing energy at the same time, because we've sort of got a commercial building stock that is not designed to be turned completely off. So a lot of the buildings sort of in the city at the moment might be virtually completely empty, but still consuming 40% of their the energy use they'd be using if they were fully occupied. But I think ultimately it's too soon to say whether it is adding to energy or just moving it from one place to another. But yeah, I think it's important to just reflect that simply just decamping from an office building isn't the answer here.
Thanks, Jen. This next one from Clemens Brenningmeier. Sorry if I've butchered your name there. Is it correct to state that if an existing building is an all electric in operation, i.e. not gas boilers, then it will automatically be Krem compliant?
It's simply put, no, because there's a couple of reasons. The Krem trajectory is based on two metrics. It's based on greenhouse gas intensity and it's based on energy intensity. So in the first instance, it will fail on the energy intensity. I will almost certainly say, unless it is a highly efficient building. And on the emissions intensity as well, it is also likely to fail because that is based on a grid average. So that is heavily linked to the amount of energy you're using rather than just say going out and procuring green energy. That's not even considered in Krem. You need to get the building right first and then look at doing that extra stuff around offsets and renewable energy. So simply moving all to electric is not going to be good enough of the current trajectory, unfortunately.
Thanks, Richard. We probably have time for just one more question. There's quite a few we haven't been able to get to, but we will come back to you all individually if we haven't made it to your question today. So just this last one from Marius Vermack. Do you think regulation should take a firmer approach to forcing businesses to develop properties / fit outs that are not only Paris Agreement aligned, but also places of greater value on data capturing systems whilst in use? If so, how do you think this can be done?
So I think the most important thing is that we do, as an industry, start declaring performance, and there's obviously a consultation out at the moment from BEIS around making annual disclosure of energy performance mandatory for all buildings. And I think that that's a really important first step. If we want to reduce operational energy use, we need to be measuring and declaring operational energy use. But I think the next step after that is going to be understanding what the impact of that policy has, whether it is simply enough to sort of name and shame the poorer performers into improving. I suspect that it's going to be a mix of incentives and regulation, but I think the first step needs to be really that incentive around declare performance and really reward people for that are reducing energy use within their buildings.
I think I would just add to that, as someone who used to be a lobbyist myself, I'm always going to extol the virtues of yes, regulation needs to be in place, but it only has a role, as Jen says, it's not a total solution. And that's actually where the investment angle is really positive. Because it is businesses taking a lead and investors taking a lead far beyond what regulation is trying to do. The requirements that they are asking for are going much further faster, and we need both those drivers as well as regulation in order to make sure that we can transition our built environment in less than 30 years.
Thank you. And thank you to everyone who has participated today. If there's anything you'd like to revisit, we will be posting a recording of this presentation on our Condor Global YouTube site, where you can also find the links to previous presentations and webinars that we've done recently. Thank you to everyone for attending today, and we look forward to seeing you all soon. Have a good day.
Thank you all.